Good morning, students. So, this is a list of common anions we are using while we need to form some formula for compounds. For example, there can be monovalent anion, bivalent anion, trivalent anion. Mono means one. This mono means one. This means one. Bi means two, and tri means three. So, anion is a you can say ion with negative charge. So you can see when we talk about bromide, IDE, chloride, iodide, hydroxide, nitrate, nitrite, hydrogen carbonate, cyanide, permanganate, chlorate. Here always the charge is -1 on all these species. Similarly, we can have some bivalent anions, sulfide -2, oxide -2, carbonate -2, sulfate -2, sulfite. Look at the difference. ATE is -2, and when it is ITE, then it is SO3 2 negative. Magnate, MnO4 2 negative. Oxalate, C2O4 2 negative. Chromate, CrO4 2 negative. Dichromate, Cr2O7 2 negative. So these are the examples for bivalent anions. Similarly, we have some trivalent anions also. Nitride, N3 negative. Phosphide, P3 negative. Phosphate, PO4 3 negative. Borate, BO3 3 negative. Arsenate, AS, arsenic. This is the symbol for arsenic. O3 3 negative. So this is the first part. You need to remember these formula for anions. Similarly, first of all, what happens? First of all, we will have some ions. Ions are nothing. They are charged species. They are charged species. So we can differentiate or classify these in two categories. First one is anion. Those ions which are having negative charge. And second one is you can say cation. Those ions which are having positive charge. Okay, so let me show you some examples for cation also, and you need to remember these all anions with their respective charges. So you can write it down in your notebook. This list you can make so that the learning part become easy. So here we are having some examples for cations also, and you can see we classify cations also in monovalent, bivalent, and trivalent category. Hydrogen H plus 1, potassium K plus 1, sodium Na plus 1, silver Ag plus 1, copper Cu plus 1, gold Au plus 1, ammonium, this is important, NH4 positive because this is a polyatomic cation because we are having more than one atom. Barium plus 2, calcium plus 2, magnesium plus 2, zinc plus 2, cobalt plus 2, copper plus 2, iron plus 2. Similarly, we are having aluminium plus 3, chromium plus 3, iron plus 3, gold, Au plus 3. So you can see here, few cations are having more than one charge on them. Like here, we are having copper plus 1, we are having copper plus 2. So that this depends, like with which anion they are going to mix up with. Here we are having iron plus 2, here we are having iron plus 3. So you need to be little bit attentive when you will be dealing with these cations and anions combination. Okay, so you can write it down in your fair notebook, and you need to remember these monovalent, bivalent, trivalent cations with their respective charges. Then the exercise to form a formula for a respective compound will become easy for you. So let me help you. like how can we use these symbols and their respective charges to make formula for chemical compounds. Okay, first of all, like you need to make formula for aluminium chloride. So we will write the cationic part aluminium. Symbol is Al. The charge was +3. So you need not to write symbol here like positive, negative. Aluminium chloride. What was the symbol for chloride? Chloride is a anion. Charge was -1. So I need not to write respective signs like +3, -1. You just write the numbers. First step is this: aluminium 3, chloride 1. Identified the cation and anion, then write their respective charge. Now you need to cross multiply like here. So we will be having one aluminium atom, and then we need to cross multiply this by this. Then you will be having 3 chlorine atoms. So this is the formula for aluminium chloride. We can see one more example, like we can say iron sulfate. So iron sulfate, we can write the symbol for iron, and the charge was 2. Sulfate. Sulfate is a polyatomic ion, SO4. Charge was 2 negative. So here you need to note something. The numbers are same. So we will be dividing both numbers by the same. So what will be getting? 1, 1. Now step 1 is clear. Now what is step 2? We need to cross multiply. So Fe 1. So 1 atom for iron, and this whole is single entity. So you will cross multiply this. So this is the symbol for iron sulfate. So I can write it like step 1 is step 1, write symbols with value of charge. Charge on cation and anion. So this is, you can say, step 1. This is the step 1. Write symbols with value of charge on cation and anion. And what is step 2? Step 2, cross multiply. Cross multiply the values. So these two formulas, these two steps, you need to remember. We can try few more examples. Next, we need to make formula for magnesium chloride. So magnesium is cation with +2, chloride -1. I told you need not to write the charges sign. Step 1 is clear, magnesium 2, chloride 1. Now what is step 2? Cross multiply. So we will have 1 Mg atom and 2 chlorine atom. So this is the formula for magnesium chloride. Next as the example we can try is aluminium oxide. Aluminium sign +3 because this is a trivalent cation. Oxide O atom, charge was -2. So oxide was bivalent anion. Now first step is clear. I wrote symbols for aluminum with their respective charge. Oxygen symbol is oxygen symbol with charge 2. Now you can cross multiply. So this will be Al2 and you can cross multiply. So O3. So this is aluminum oxide. Next, one more example, you can see calcium hydroxide. So calcium plus 2 hydroxide OH minus 1. We need not to write the signs. We just need to cross multiply. So this will be calcium and OH whole twice. So this is calcium hydroxide. So this is your kind of homework, dear students. After writing the formula for different cations, different anions, you can try to make the chemical formula for these given compounds. And if you find any difficulty, please let me know. I will be here to help you. Thank you so much. Have a good day. Keep learning.